Brilliant. Thank you very much for the warm welcome. Good evening. So I'm Scott, and this is talk about app security, but crucially on a shoestring budget. And you'll see as we go through kind of what I mean by that. Just to sort of intro myself and let you know who this guy is at the front in 3 bullet points. I'm a freelance Android developer. I sort of develop by day, but I'm kind of quite interested in mobile security, kind of hence the talk. And a couple of years ago, I got involved in the Android security cookbook, and that's got a load of kind of like Android hardening techniques as well as kind of penetration testing stuff. And the last thing I thought you might find interesting about me is that I run a similar group to Londroid, based up in Bristol, which is for mobile developers of all kind of creeds, iOS guys as well, which I know is a bit of a contentious thing in here. But yeah, that's me in 3 bullet points. And today we're focusing on a kind of more of a story of app security based on a development experience of mine recently. Don't worry, I've included a padlock on this talk so you can trust it for sure. And what we're talking about a story, an app I worked on in the past, but I definitely have to put out a disclaimer so that I don't get into any trouble and no one can know who that client potentially is. So let's pretend it's fictitious. So I'm sure this is a generalization, but I'm sure people in this room have been in meetings with guys like this. And what I'm trying to sort of generalize and say is that, clients and project managers and stakeholders who just don't get things like, like code quality, like architecture, and security risks. Their focus is on time. Project managers want features delivered by a certain time. Clients they don't understand why what the security risks are. And also, they don't want to pay for them. They don't want to spend an extra 2 weeks developing, and that's X amount of money. And we can't let that stop us from putting security into our apps. The answer tends to be always, it's okay. We're using SSL. Has anyone had that kind of conversation? We're using SSL, so it's okay. We don't need any extra security. We're not taking credit card details, and we've got SSL. Thumbs up. Job done. We're not storing nuclear launch codes, so Scott, that security requirement, we don't need to do that. That's kind of the experiences that I had, and this was always my kind of reaction to that comeback, because ultimately it's our reputation as developers with all the apps that we develop and we talk about, with our profile. That reflects badly on us. If an app that we've developed is hacked and the users are compromised, I think that reflects badly on us. And I always feel that massively. As I sort of said earlier, I've kind of co-written a book in security. I get up in front of people and talk about mobile security. So if stuff that I've worked on is easily hacked, then I kind of feel like one of you would call me out on it. So hopefully that won't happen tonight. So what can you do? You've tried to convince stakeholders and clients and those kind of people that you should do some additional work on security. You could try and get them to sign something to say that, hey, that you won't get fired or you won't get fined, the amount of money for each of those users that is compromised. But what I decided to do was take a leaf out of Shia LaBeouf's book, and just to do it. And by that I mean just to put these security enhancements in, and we'll go through the kind of things I put in. But this is kind of the opposite of what a backdoor is, and I guess what would you call that? Like a front window? I don't know. But that's what I decided to do, and that was the inspiration for this kind of talk. So I decided that I would split the enhancement work that I would do into what I called 3 sneaky sprints. Yeah, you can see I'm a comedian. And this kind of loosely kind of coincided with the work we were doing on the app at the time. We started off writing the API code and the parsing stuff. So at that point, I worked on how we can increase the security of that connection, between the app and the server. Next, we were looking at storing data, caching things. So I looked at the integrity of the device and sort of data encryption. And then lastly, after doing sort of the UI and all that kind of coding, we start to focus on the APK once it's kind of live, out in the wild. So this work and this whole like shoestring budget is the fact that this work was squeezed into contingency of other tasks, and and then where that wasn't possible, top up in lunchtimes and evenings. So let's get started with our first kind of sneaky sprint, and the first kind of focus is network. I kind of already mentioned we're using SSL, so that's a really good start. I kind of was mocking of it earlier, but that's a great start. But what we can do is we can make that the connection between the app and the server stronger. I'm going to use OK HTTP as some of the code examples in this, just because it's become pretty much the de facto on Android, but you can still do these techniques with other libraries like even just the straight HTTPS URL connection. You can still do all this stuff, it's just probably more code. So to start off with, we're not going to go into all the kind of details of how SSL works and the different sort of key exchange and things like that. We could do a whole presentation on that. That's not tonight. The basic kind of principle of this tip is that you want to increase the encryption quality of the connection between your app and your server, and you can do this by only using the stronger cipher suites and the most recent TLS version. And if you're not sure what those are, as often when we're developing apps, we're completely insulated from the API guys. Certainly, I've found that in all the agencies I've worked for. You never hear from the API guys, even when stuff goes wrong. So what you can use is something like SSLlabs.com have a SSL test that you can just point your API URL at, and that will give you kind of like a rating of how secure the SSL configuration is. That's all great, but what you're focusing on is what cipher suites it supports. What's nice about the SSL Labs tool is that it tells you what versions of Android those cipher suites are supported on. So if you've got a minimum SDK issue, you can just go through that and find out what the strongest one is for your for your minimum platform. So that's the first thing you can do. The next thing you can patch against potential exploits. So the security in Android and the cryptology and stuff is all based on like a provider, and that provider, there can be vulnerabilities found in that provider, and there has been with things like OpenSSL. The cool thing is that Google Play Services allows you to update a device's a security provider. It's really like it's a one-liner if you want to do it that way. There's a great training article actually on the developer docs about how to do this, and you kind of you put that in your application on create object, and that will then run that if the device is if there's an issue with that. The key point of this, and the reason why I'm sort of mentioning in this talk, is that the Play Services is updated a lot more frequently than the OS is. If you're lucky and you've got a Nexus device, you're going to get those monthly updates, which are awesome, and monthly security updates. But if you're not, you could be waiting weeks, months, years before a patch to the Android open source project makes its way into the onto your device, if it ever will. So this is a good way of doing it. And the great thing about this is that only one app on the device needs to run this. So if someone's already run this to make sure that the provider's up to date, this will just return almost straight away. So that's another cool thing we can do. The last thing from an SSL point of view is we could look at putting in some SSL pinning. And for those not familiar with SSL pinning, it's just a kind of way of limiting the certificate authorities that we trust when we're doing our SSL connections. And the kind of issue is that all our Android devices ship with well over 100 certificate authorities, and if any one of those are compromised, which they can be, they have been in the past, you could have a malicious certificate authority employee. And of course, a lot of stuff that came out with the revelations that Edward Snowden sort of revealed is that there's definitely some grey areas between some of the root level CAs and government agencies. So what we want to try and do is limit who we trust effectively. And there's two ways of doing that. You can actually pin the actual certificate, or you can pin the public key in the certificate. You don't have to worry about the kind of details of this so much, because it's really easy to sort of implement using OKHTTP. This is just a really quick code example of how you would do that. It's just showing you when you create your OKHTTP object, you're using the pinner, certificate pinner object, and you're supplying that with the pins. If you're not sure what the pins are, that bit.ly link is to a little project I wrote, which is just really simple jar, a command line jar that you can run. You point it at your API, and it will give you the pins. It will go through the certificate chain and just generate a pin for each one of those, and you can just copy and paste that in. It's worth noting that you should definitely use the latest versions of OKHTTP because there was a vulnerability found recently. So again, this kind of like is hitting what we're aiming for in the context of this this project that I was working on. Stuff that I can just quickly and easily cut and paste in, and using open source libraries and stuff we already had. The sort of next part on the networking side, the app used web views, and whilst I'm not going to try and sell web views to you, and I'm sure a lot of you sympathize with the pain that web views can cause. They do have their place, and certainly in this app we were using it for things like privacy policy, help page, FAQs and stuff like that. Stuff that you definitely don't want to have to push an app update for. But the web views are potential issues of vulnerabilities and things like cross-site scripting. So what you can do if you're just displaying static pages is you can disable some of the risky settings, and most of the security issues around WebView come from the JavaScript interface and JavaScript generally. So you just disable that. Same with file access as well, you can just disable that. The other thing you can do is you could whitelist the domains that you're accessing, because you know that you're displaying specific content. I wrote a quick gist of just like a safer kind of web view that you can just pass an array of whitelisted URLs, and then it will check for every connection that it tries to make that it matches that list. Just simple things we can drop into our project just to make it slightly more secure. That was the kind of it for the networking side, and then we kind of moved on to device integrity. And then we were also caching some data, because we wanted, as we all hopefully do, want our app to work offline. So this kind of sprint focused on that area. So when we say device integrity, we're really thinking about our friend root. And there's nothing inherently bad with rooting your device. If you know what you're doing, then go for it. But you just have to understand that the standard system security, doesn't apply anymore. And the most kind of fundamental sort of part of that is that, we're all kind of used to our apps having our own little private folder, private sandbox where we can store and read files from that only we can access. On a rooted device, that's no longer kind of guaranteed, effectively. Attackers, malicious apps, and the user can be elevated to root level permissions to sort of access that. So, there's a couple of things we can do to check devices, the root status as well as kind of the integrity. The caveat, certainly with any kind of root detection, is that, root is God effectively, so there's no way to 100% check for root. There's always ways around it. But there's a couple of things to make it a bit harder. So there's two open source libraries that I've helped write that can help with this. Root beer is a library I wrote with someone else that it basically tried to bring together all the kind of root checks that we saw on Stack Overflow, a few of the ones that we had we wrote ourselves. It has a native root check as well in there. And the idea was to try and beat some of the kind of more popular root cloaking apps. And it did a pretty good job at defeating some of them. We found you could defeat it with using a couple of them together, like using an exposed module and the standard sort of root cloak. You could beat it, but it was pretty good at sort of beating most of them. That's probably changed since we've written it, but yeah, it's kind of like, again, it fits the context of what we're talking about. It's something we can put in to sort of detect root on a percentage of devices. And the other one you could look at is the safety net API. It's another thing that's part of the Google Play services, and it's probably something that I think doesn't get enough love and enough press. So much so that I wrote a little wrapper that sort of goes around it, makes it a bit easier to use. Again, this kind of ticks our box for being something we can drop in and call and be easy to use. And what the safety net sort of API does is it checks the device for various different vulnerabilities. You know, earlier we talked about the updating the SSL provider. You know, if that was kind of an issue, that the safety net test would sort of pick that up. The side effect of the safety net test is that it will also detect rooted devices, even though it's certainly not something that Google sell it as. It's not sold as a kind of root checking library, but it does detect that. So these are just two things you can do, two libraries you can use to sort of help verify the device integrity. I should just add the caveat with the safety net wrapper is really nice, and listen to me saying it's really nice, I wrote it. It's really easy to use, but it doesn't do any kind of server-side validation. And when talking to the Android security team, they were saying about that being pretty important, because if the device is rooted, then that can be faked. But as a kind of first pass, it's worthwhile doing. So that's to sort of help with the device integrity. Now let's look at the data that we're storing. So we were storing things like access tokens and things like that in the shared preferences. So a very easy and quick upgrade to shared preferences is to use something like secure preferences, which again I helped write. Or you could use something called Hawk, which is a better name, more stars on GitHub, and it's got a logo. So you make the call. But it's just a way of shared preferences. For those who aren't familiar, is backed by an XML file, and so on a rooted device or a compromised device, you can very easily see what those are and modify what those are. And in the old days, when some games used to store like the number of coins or the level you're on or sort of your high score in shared preferences, on a rooted device you could just go in and change those. With this kind of library, you couldn't do that. You'd have to reverse engineer the app, work out how the key is generated and what the key is used, and then decrypt the data. So it makes it that more difficult. And the same thing goes for SQLite. We were using SQLite to cache a bunch of data so we could use offline. So a straight replacement for that's more secure is SQL Cipher for Android. That sort of transparently encrypts things in the background. And the reason why I've sort of put obfuscate in brackets, because we're encrypting this data. We're storing it encrypted, but we're not doing anything sort of clever with the key. We're storing the key with it in the same place, so it's not kind of truly kind of secured. But again, the point I'm trying to make is you'd need to reverse engineer the app to sort of work out what that is. You couldn't just extract the DB file from a rooted device and start playing with the data. If you're using Realm, Realm have a similar kind of encryption option that you can use. Just thought I'd mention that. If you're doing this the proper way, and this wasn't something we had time for, and certainly not in the context of this app where we're sneaking stuff in, this is quite a big kind of UX change. You could put in something like an app pin code. And the app pin code you would use then using like password-based encryption to generate an encryption key. that would only ever be stored in memory, and then that would you'd use that to encrypt the data. So that's a bit safer way of doing it. You could also use the Android key store, which is linked to the device pin or passcode, and also in Android 6, that's kind of linked to the fingerprint reader as well. So that's how you do it in an ideal world, if you could sort of put those requirements in. So that's the kind of end of the kind of encryption part. Now we kind of we went away. We carried on working and doing the UI code and stuff. And just before kind of coming up to releasing the app, we started thinking about how the app in the wild and this sort of APK, that being reverse engineered, and what we can do to sort of make that more difficult. So the first thing that I put in was a tamper check, and this is a really kind of simple check that you can do in a couple of lines of code, and it's all based on the principle, the fact that all apps on Android require to be digitally signed. You guys all know that we've got key stores, we sign it, and it's part of the thing we do. And if you try and upload it to the Play Store without it, you get an error. And the key thing here is it's consistent for the life of the app. And we know that if we try to publish updates for our app and it's not signed, if we signed it accidentally by a debug key store, then we get the certificate error. So we know the certificate's going to be the same throughout the life of the app. So what we can do is at build time, we can go and get a signature of that key, and using the package manager at runtime, we can get it again and compare them to see if they're the same. So really simply, you can use something like the key tool, just to list using that command, and that will give you the SHA-1, and you can just embed that in your app. Embed is just it's a string. And then at runtime, like I said, you can just get the package manager, hash a string, and then compare the hashes. There's a full code example of that on one of the blogs that I'll link to at the end, and as well in the book. But of course, this tamper check with the idea of this is to sort of guard against someone taking your app, decompiling it with something like APK tool, and then putting in some malicious code and then re-signing it and then duping your users into installing it. At least with this check, it kind of helps that. They've got to then go through your code and then find out where this tamper check is and remove it. We can make that a little bit more difficult if we obfuscate the code. I'm sure most people in here have heard of ProGuard. So I'll just draw your attention to the bottom line there. Turning it on, very easy. I'm sure if we've all played with that, it's just that easy, isn't it? You just enable it. So it's obfuscated. Game over. Next slide, please. Of course, it's not that true, and I found this a few last year, and it really kind of spoke to me. And we sort of saved the hardest bit to last, using ProGuard. And just wanting to sort of talk about a few tips around using ProGuard and putting it into your app. Certainly try and add it as you go along. Add any explicit config that you need for any third-party library you add. If it hasn't got, typically they'll have a ProGuard configuration. If the library developer is on the ball, you can now include those automatically. But add as you go along. Having to go through all your dependencies and stuff at the end of a project is time-consuming. I use it personally to strip all my log statements out, so I don't have to worry about bleeding any kind of personal kind of data, personal logging stuff, to the system log, which is always a good thing. Thing to also remember is that your stack traces will also be obfuscated. So finding out what's gone wrong. I'm sure none of us, make apps that crash, but it has happened once or twice to me. So I thought I'd mention it. And so what I use pretty much religiously is Crashlytics, as they automatically handle the ProGuard mappings file upload and then the auto deobfuscation of the stack traces, which is pretty good. The Play Store actually now supports the uploading of ProGuard mappings files as well now. That was only in the last couple of months. I think that's pretty cool. But it's something to bear in mind. It's something we used to, when I've worked on projects in the past, we used to sort of like factor into like bug fixing time, because you'd have to then go and find the right mappings file, deobfuscate the crash trace. But now that's kind of done automatically for you, so it's quite handy. You might want to look at, there's a Gradle ProGuard plugin which will automatically generate some of the configs that you might need from certain libraries. That's something that might help you out. And the other thing to consider as well is the paid option, DexGuard. One of the reasons I like it is that once you've done all this heartache that it can be with ProGuard configuration, switching to DexGuard is the same config file. It should all work. It's just a stronger kind of level of protection. And going back a couple of slides, we embedded the signature of our app certificate. You could target that class that's doing the tamper check or the root checking, or even your classes that are doing the SSL checking. And you can sort of target those and encrypt them and hide them, so you can have specific hardening stuff on those. So that's worth, if you've got a license, not that you'd have a license lying around and not know about it, but it's worth using if you've got it for like one app. Yeah. So that's it. We hit the deadline. We passed all the user acceptance testing. We hit the magic publish button, and we all know what comes next. It's it's profit, it's riches, it's amazing. But so what? We snuck these changes into this app, but what was the results? What was the point? Starting with the negative things, we definitely we added more code, so it's definitely a more complex app. We've made the APK size bigger. Adding things like SQL Cipher is going to bump your APK size up 7 to 9 meg. That could be a limiting factor for some people. We made our app slower. We're using encryption. Things like SQL Cipher that on the site they talk about it slowing down to like 5 to 10%, which isn't massive, but it's still, we've still slowed it down. And we've slowed up our startup time as well, because we're generating those encryption keys. We've used encryption, but as I kind of said at the time, we've only really obfuscated it because the keys stored in there as well, so that's not ideal. And as I kind of joked, that the ProGuard config was time consuming, and that was several late nights getting that working. And also, we didn't get any credit for all our hard work, which is a shame. But on the plus side, we did make the app less vulnerable to man-in-the-middle attacks with all our SSL enhancements. We made the web views less vulnerable to cross-site scripting and other vulnerabilities. We by doing by using that encryption, even though it's only obfuscated, we made it harder for attackers just to simply edit our data using like another rooted app, to change our preferences and things like that. We made it so that on a vulnerable device or a rooted device, then people are gonna have to actively circumvent that. Again, it's more time and more skill level. The tamper check is going to hamper the recompilation, and then the obfuscation makes the actual decompiled code harder to read. So did we win? We didn't create a 100% secure app. But that was never the goal. We were talking about minimum effort, maximum gain. We were on a shoestring. We were kind of hiding this stuff. What we did do is we increased the skill level to attack the app, certainly above that of an automated attack, and crucially above that of someone reading a blog about how to reverse engineer an Android app, which there are tons out there, and there's some really good articles about how to do it. And if you haven't done it, I suggest you do it to your own apps, because it's good fun. But hopefully with these things we put in, we've taken it above that level needed. And the other thing we've done, crucially, with the skill, we've also increased the time it's going to take to attack our app. And that's going to, unless they're really, attackers are really motivated, they're just going to move on to the next app. There's hundreds of apps without any security in, so why not just move on? So did we win? I think we did. I think we've, we leveled up our app security. We acquitted ourselves and protected our developer reputation. And perhaps more importantly, we've maybe have saved some of the app's data and some of the app users' data and their privacy. So if you're in this situation, similar to I was, and you're thinking, what can I do, to improve an app security? We just talked about, over 7 things that you can just put in, to improve things. And I guess just lastly, I should finish on a famous quote. Should you do this? Should you go back to your day job and do this? Because really, sneaking code into an app, in a professional environment isn't a good thing, really, is it? And I guess, you're an adult. It's up to you guys what you do. But hopefully, what this presentation has showed you is that there are some really like low-hanging fruit, as another kind of phrase people band about, that you can sort of do to improve your app security without kind of breaking the bank in terms of the amount of time or the cost. So hopefully that's the main sort of takeaway. Here's some resources. The slides are on speaker deck already for anyone who wants the slides. And thank you very much for listening. Cheers. Questions? Yeah, of course. I'm just fucking with you. Sorry. That's too. Sorry, was the question? So the question was, do we add any kind of analytics or anything to the app to see if these security changes made any difference? One thing I didn't cover was that what you do when you detect like the app has been tampered or whether it's been rooted or on a rooted device. One thing we did in this app was to add like a custom analytics event, so at least we knew that on those, for the sort of newbie hackers that were trying it, that event might go. Proper skilled attackers would do like in a Faraday cage in a box. But that's the kind of the thing. The only thing we really did to sort of test whether it had been tampered. And that's the tampered one is a key one, assuming that tamper check's still in there, of course, and they haven't sort of taken it out. But I'm not sure that what you could do apart from that kind of stuff to validate it. I guess you could. One way would be to sort of get it security pen tested and get their results and things like that, which is definitely something you should do as well. But again, like I was saying at the start, there was no requirement on no kind of effort. People wanted to expend effort to actually put this stuff in, so let alone test it. But yeah, good question. Another question over here. So the question was, so if you're running on a rooted device, the check we were doing, what were was the purpose behind that? And you were suggesting whether you would just stop the app from running. You could do that. A lot of the banking apps do that. Or I guess because I kind of have rooted devices, I kind of prefer the option of just letting the user know. I mean, LastPass do that. They say, hey, you're running on a rooted device, it's not as secure. You should know this, So you could let them know. You could get them to sort of sign it, click to agree, so you kind of absolve the company of any issues that are caused by its routing. You could decide not to work offline on a rooted device because you can't guarantee that any data that you store on there is going to be safe. That could be an option you could do. Yeah. Hope that answers the question. Okay. We'll go question here first.
What about the API keys? Do you have any recommendation in order to store them?
Okay. So the question was, for API keys, what would you do to sort of store them? And I guess I use things like DexGuard to using things like string encryption or class encryption, and that just obfuscates those a bit more. And if you've ever decompiled, like I was saying, definitely check out things like APK tool to decompile your apps, and you look at the code and it's quite readable. But if you decompile like an app that you've used DexGuard on, it's very, very difficult to understand where stuff is, and it's all kind of in ciphertext. So yeah, that's what I would recommend doing for that. Cool. Is there any questions over here? Okay. Just come and see me or tweet me on that, and my email's here. I wouldn't put that here if I wasn't happy to get questions about this kind of stuff. So brilliant. Thanks for coming. Cheers.